Hey guys, welcome back, and this is the third video, and we're going to be doing implicit differentiation this time, and this is the favorite topic of mine in differentiation. It is very cool. It makes life so simple. Oh my god, I cannot even start to list down all the benefits. So, first of all, implicit just means implies. So implicit refers to implies. So we're implying the derivative of something. So let's let's start off with the equation for a circle. If you remember the equation for a circle, a unit circle, let's say, a unit circle, remember, is just a circle with radius 1. So and let's say the center is 0, 0. So center 0, 0. So now the general formula for this circle would be x squared plus y squared equals 1 squared. But the 1 squared is just 1, so we replace it with just 1. 1 squared because 1 is the radius, and the radius squared is just 1. And now we want to find the gradient of the line tangent to the circle at some point. And how we do this is we want to find dy by dx because that is the gradient using calculus. So how would we do that in this situation? The normal method would be rearranging. So y squared equals 1 minus, bring the x squared over, and you get 1 minus x squared. And then make y the subject, so y equals square root of 1 minus x squared. And now we're gonna do differentiation now, the traditional method, which is dy by dx, and we differentiate this. And remember, this is just 1 minus x squared power a half, because square root is power half. So now we can use the power rule and chain rule. So when we use the power rule, you get the 1/2 down and minus 1. So we have 1/2 times 1 minus x squared. Power half minus 1 is negative a half. And then remember to multiply by the derivative of the inside. The derivative of 1 minus x squared is negative 2x. And so what we get here is, let's see, the 2 and the half cancel, but we still have a negative. And so it is, and remember this is a negative half power, so we can rewrite it as over square root of 1 minus x squared. And on the top we just have negative x, so negative x. And scroll down. And an interesting fact about this is that the square root of negative 1 minus x squared, square root of 1 minus x squared, is exactly y as we defined over here. Y equals square root of 1 minus x squared. So we can substitute that in, and we have dy by dx equals negative x over y. And this is very interesting because usually we see that dy by dx is only in terms of x. For example, if we do dy by dx when y equals x squared, we get just 2x and no no y's in the dy by dx. But in this case it's a little bit different, as we can substitute this value here for y. But there's a different method for doing this, and that is introducing a new variable. And it's really interesting because the first step is actually to increase the number of variables, because we start with the equation for a circle. That's the equation for a circle. And we say let x and y be functions of, let's create a new variable, let's call it t. So now x and y are functions of t, so we can differentiate them with respect to t. So let's differentiate this whole function or whole equation with respect to t. And remember, d by dt just means differentiating with respect to t, as opposed to d by dx, which is differentiating with respect to x. And by we should get 2x, but remember we have to multiply by the derivative of the inside because this t is not x. So by the chain rule we get dx by dt, which is the derivative of the inside, which is dx by dt, and plus 2y. And remember we said y is also a function of t, and this would give you, according to the chain rule, it would give you 2y dy by dt. This step, by the way, could also be called parametrization, which will be covered in a later topic. And for the right-hand side of the equation, it would just give 0, because any constant would give 0 when differentiated. And so now we have a nice equation in terms of dx, dt, dy, and we want to find, remember what we want to find is dy by dt, or sorry, dy by dx, because the original equation was in terms of x and y here. And we want the gradient of the circle, which is up here, and this has no t variable in it, so we can't have t in the final dy by dx. So how can we possibly get dy by dx from this? And it's a really cool trick. It's just multiplying dt on both sides, because the 0 cancels out everything. So we have, we multiply dt on everything, and we have 2x dx plus 2y dy equals 0 again, because 0 times dt is 0. And now we have only dy and dx, so we can rearrange to get dy over dx. So I'm going to move the 2x dx onto the other side, so we get 2y dy equals negative 2x dx. And let's divide both sides by dx, here and here. And let's also divide it by 2y. So 2y and 2y. So finally what we get is the 2y and 2y cancel, and we're left with dy by dx equals, the dx cancels, so we have negative 2x over 2y, and this simplifies to negative x over y. And that seemed kind of long, but when we get to the shortcuts of implicit differentiation, that will be very intuitive and very fast. And you can see that this result here is actually the same as what we got over here with our substitution. And yeah, that's basically how implicit differentiation works. And what the result actually means is, let me go back to the graph over here. Let's see. So we know that dy by dx is negative x over y. So let's look at the first quadrant here. The first quadrant, I'll just name it quad, first quad. And here x is positive and y is also positive, but the gradient is negative. So dy by dx is negative. And we can see that this negative sign, because these two are positive, this negative sign makes dy by dx negative, and that fits with our description. And let's go to the second quadrant now. So second quadrant, remember the second quadrant is always you go anti-clockwise to count up the quadrants, so it's this quadrant here. And so what we have is, let me rewrite this over here, dy by dx equals negative x over y. And for the second quadrant, we have x is negative because we're going to the left, and y is positive because we're going up. And the gradient, as we can see, is positive. So dy by dx is positive. And we can see that that works because x is negative, y is positive, so negative and negative cancel and give a positive in the end. So that works. Now let's try third quadrant. So the third quadrant would be x is negative, y is negative, and dy by dx is also negative, as you can see with this line here. And this also works out, and for the fourth, it's x positive, y negative, and this also works because the gradient is positive, as you can see from this line here. And so this description is actually correct for the gradient of the circle at any point. And to find the gradient of the circle, you need both x and y, because usually you only get the x coordinate in questions we've encountered so far. But now they might give a question like, find dy by dx at the point 4, 5. So how you would find that is plug in 4 for x and plug in 5 for y. And 4, 5 is not actually a point on the circle because it's a unit circle, but it's just an example. And so yeah, that's pretty much it for implicit differentiation. And let's try some practice problems just to get better at this. Let me go over here just so we have space. So the first problem that I came up with is find dy by dx when xy equals 6. So now this is really cool because we have to use the product rule now. So what we do is we use implicit differentiation. So remember the product rule. The product rule is when you differentiate uv, you get uv dash plus vu dash, as I derived in my other video. Please go watch that if you want to recap. And you can use this formula for xy because you can say u is x and v is y. So what you get when you plug it into that, and let's say we want to differentiate this whole equation. So we have, so u is x, so we have x. V dash is the derivative of y because we said y is v, and the derivative of y with respect to x is just dy by dx. And we have exactly what we want, but we're not finished with the equation yet, so we have to add. V is just y as we defined earlier, so y. And u dash is the derivative of x with respect to x, which is just 1. And the derivative of 6 with respect to x is always 0 because constants always differentiate to 0. And so now we have x dy by dx plus y equals 0. And now we can rearrange to solve for dy by dx. So dy by dx is equal to negative y over x. And that is the answer for this question. So next question, let's see. Okay, so let's see. Okay, find dy by dx. Also feel free to do these questions as I'm writing them, or pause the video to try them yourself. When is it lagging? Oh no. Okay, when 2x squared minus 3y squared equals 5xy. So now this is a bit more complicated than usual because we have to differentiate both sides, and there's no simplification allowed here because you have x over here and xy on this side, and x and y separately on this side, and xy on this side. So there's no way of reducing that. So now what we do is we differentiate both sides. So let's put the d by dx, and we have on this term here will be, by normal differentiation rules, would be 4x because we bring down the power and minus 1 from the power. And this term here is a different story because y is a function of x, not x itself. So we have to use implicit differentiation. So first we bring down the power. So we have 6, and we still have y, and then we minus 1 from the power. So this is just 1, but we don't need to write that because y power 1 is just y. And then we have to remember to multiply by the derivative of the inside by the chain rule. So we have dy by dx. And this is equal to, we use the power rule here, or sorry, the product rule here to find the derivative. And we have 5 times, in big brackets because we're differentiating this inside function, or xy. And what we have is, let's see, so let's do this in our heads. We have x times dy by dx because we keep the first term and differentiate the second term. And then we have plus y times dx by dx, which is just 1. And so now the full equation would be 4x minus 6y dy by dx equals 5x dy by dx plus y. And now we want to separate the terms that have dy by dx because this is, the dy by dx is what we want. So we want to separate those terms away from the normal terms. And so we do that by rearranging. So 4x, let's bring the y over to the other side like this. So 4x minus y. And let's bring the 6y dy by dx to the other side. So we have 5x dy by dx plus 6y dy by dx. So now we can take the dy by dx common. So we have 4x minus y equals 5x plus 6y all times dy by dx. And now we can just divide both sides by this. So we have dy by dx equals 4x minus y all over 5x plus 6y. And this is amazing. Like, this makes life so much easier because you don't have to rearrange this entire equation to get y as its subject. You just have to implicit differentiate, and you can easily get this as your formula. And so yeah, that's pretty much it. Implicit differentiation is a really interesting topic. You guys might want to look more into that if you want. And yeah, as always, leave comments to help me improve my videos, and thank you for watching.